Hello, hello. This is newly re-recorded version of my Snackdoku Solution videos. This is going to be 6 in 1, which includes one snack that hasn't had a solution video made for it yet, I don't believe. No, I did. I already did do one. I just didn't include it in the same video as all the other ones because I didn't feel like re-recording all of them just for that, but now I have an excuse to record all of them because I added hints to all of these puzzles, and I just wanted to include that in the video form here, and these are all very quick to solve. So all 6 of these together will probably be around the same, if not shorter, than the length of any of the other videos I've done on full puzzles. So Snackdokus are all usually mini 4x4, sometimes 6x6. Sudoku puzzles that are generally easier solely by the fact that there's only so many things you can cram into a grid this small, as far as clues go, that aren't just immediately trivial. So some of these are basically immediately trivial, but again, they're meant to be introductory. That's sort of the idea. At least behind most snacks. Not all of them are. Some are actually really surprisingly difficult, but the ones I made here are all generally approachable. The first few will be much easier. I've ordered these roughly in order of difficulty for the video's purpose here. So, first one is Slow Down and Have a Snack. This one was made in collaboration with Carabet at SudokuCon 2025, where we were doing a Snackdoku setting, and a lesson, so to speak. And so we just kind of collaborated. It really didn't take that long to make. Calling it a collaboration is kind of a bit overkill just because we were done in like 10 minutes. It wasn't that hard of an idea to come up with generally. We just kind of worked together on how we wanted to place the thermometer into the grid. Yeah, so it's 4x4 Sudoku rules. So 1 to 4 in each of the boxes. That's going to be the same for all of these puzzles, except for one. One's a slight exception to that, but they're all 4x4. The only rule in this puzzle is a slow thermometer. Digits on gray thermometers either increase or stay the same as they progress from the bulb to the tip. And so if I were to give any sort of like example on how that works, I'd be practically solving the puzzle, so I'm not going to give an example right away on that. But I will say right off the bat, hint number 1 here is the only hint actually, so the hint here is there's only one way for this slow thermometer to exist without breaking the puzzle. It can be quite helpful to pencil mark thermometers, whether they are slow or not, so you can more easily see how the digits must ascend, or stay the same in this case, as you move along them. So normally I would say you start minimizing the digits and maybe take note of what the minimum case could be, and then do the same for the maximum case and work your way down. Here we don't even need to do half of that. We can just start by taking a note of, at minimum this would be 1. This would have to increase, even though we can keep digits the same. Sudoku rules don't allow for that in this box. You can't just have a second 1 in this 4x4 up here. Similarly here, this could not just be another 2, that has to be a 3. This could potentially increase, but it could also stay the same. So let's assume that it increases, and say we make that a 4. What would this be then? Nothing. You can't have another 4 here, you can't have a 5. So this cannot increase. This must stay the same, and become a 4 there. And the fact that we just proved the other case doesn't work, that tells us this is the way this thermometer must go. This is the only way to fill it. And so now this is going to be very easy to fill the rest in. 3 can't go here, so that's a 4, that's a 3. 2 and 4 in this row. We already have a 4 here, so that's 2, that's 4, that's 1. 2, 1. 2, 4, and then 1, 3. So that one done in 1:52, and that was with the explanation there. So this one was very quick. So that was Slow Down and Have a Snack. The second one we'll do is Look at What You're Saying. And so, again, same idea. There's just a single hint for this one. Open up the Sudoku pad link. Let's not resume it. Let's restart. And so here we have two rules this time. Same 4x4 rules, 1 to 4 once each, row, column, and box. Then we have Look and Say cages, which are not the most common type of cage. Usually when you see a cage, it's summing to the total in the corner, which would mean these would sum to 34, which is wildly impossible with a 1 to 4 only grid. These are Look and Say cages instead. So digits in dotted line cages specify how often a specific digit inside it appears. The tens digit is how many times, and the ones digit is which number. For example, if a cage was labeled 23 or 23, you'd read it as 23, and you would say that there are 2 3s in the cage. The only other rule here is we have a single white dot consecutive pair, meaning these numbers must be consecutive. And so the main hint that we have here is there's only one way to distribute the numbers in each cage, given that there has to be 3 of them in each, and you can't repeat digits in boxes because of normal Sudoku rules. The rest of the puzzle should fill itself in once that's done. And so the way we think about that is this cage needs to have 3 4s inside of it. We're only going to be able to have one of them up here just by Sudoku rules, so the other 2 are going to have to go here. So that's 4, that's a 4. And as soon as we do that, these 4s lock out the other 4 from existing in that, and it must go here. And the exact same pattern will hold with the 3 2s over here. We have to have 3 2s, one of them will be here, the other 2 are going to be over there. Sudoku rules lock that out, so we get a 2 here. And that now allows us to place our last remaining 2 up here and our last remaining 4 down there. And now the white dot will tell us the order of everything else, because everything else is 1 and 3 in some order. And this 4 cannot be consecutive with 1, that must be a 3. So that now tells us the order of the rest of these. And that one, also done in just under 2 minutes from start to finish, not too bad. Again, really just trying to kind of speed run through all these. Next up, we have hot cages. This one has 2 hints on it. Not because I think it really particularly needs it, but mostly just because I was able to find an excuse to give 2 separate hints here. So here we have, again, 4x4 rules, same as the other ones, 1 to 4, once each everywhere. This is a normal thermometer. Technically, you could call this a slow thermometer too, and say that, technically you could say digits could stay the same, but they really can't because it's all in the same row, but this is just a normal thermometer. So digits must increase as you move away from the bulb, here to here to here. Now we have normal killer cages. These 2 numbers must sum to 5 because we have a 5 in the corner. These 2 numbers must sum to 6 because we have a 6 in the corner. So, first hint we have here, similar to the other one, it says, it can be helpful to pencil mark thermometers based on how the digits must increase. For example, row 2, column 3, which is this cell, is either a 3 or a 4 in order to avoid breaking the thermometer. And the way we would approach recognizing that is that minimum this is 1, minimum that is 2. So minimum this would be 3, and it could just potentially be a 4 as well at that point. And what you could sort of see is because this is a 3-cell long thermometer and we have 4 digits available, we kind of get the snaking effect, where this is 1 or 2, that's 2 or 3, that's 3 or 4. And that represents the fact that we have what we'd say 1 degree of freedom on this thermometer, where we're allowed for each of these digits to adjust by no more than 1, because if we made them adjust by more than 1, like if we made this a 3, that would have to be 4, what would this be? So that's the first hint there. So that recommends, just doing pencil marking along those lines. And so now that's going to give us some info about the cage here, because if this is a 3, that's a 2. If this is a 4, that's a 1. And that now gives us a 1-2 pair in the row. So this cannot be 2. That must be a 3, which means this must increase to become 4 there. That tells us the cage, 4 and 1, 2 there. And now hint number 2 here, which, depending on how new you are to this, you may or may not even need the second hint, but it just points out that there's only 1 pair of digits for the 6 cage, since this is just a 4x4 Sudoku. Normally there'd be 2 options. You could have 1, 5, or 2, 4. But in a 4x4 puzzle with only the numbers 1 through 4, this has to be 2, 4 in some order. And it says resolving row 2 will tell you the order of those digits. And that means we have 2, 4. This 4 breaks up that order. So now we have enough info to classic Sudoku to the end here. So 1 is locked out of here, so 1 goes there. That pushes a 1 here and pushes a 1 there. This must be 4 to finish off the box. That's 3 and 2. 4, 3, 2, and 3. And so you'll find this quite often in these 4x4s, that the numbers really just kind of fill themselves in. Once you get a couple of them, it falls very quickly. So that was hot cages. As you can tell by the title there, that was just a little reference to, thermometers and cages, but sometimes I'm clever, sometimes I'm just really lazy with titles. The next one, we have a nice nightly snack, spelled KN, so like the word night, like a chess knight, for example. And that's highly relevant for the rules. We have, once again, 1 to 4, once each everywhere. Then we have anti-knight. Cells that are a knight's move apart in chess may not contain the same digit. So if we just determined this was a 1, we could already say where the 1 must go in this box down here. Because 1 can't go there by Sudoku, but knight's move, a knight move is 2 away and then 1 over in every direction. So 1 is not able to go in either of those spots, based on just knight's move rule. It also cannot go in those spots by Sudoku. So not only do we get a 1 down here, we would also get a 1 here, and then the final one would have to go there. That clearly does not work, because I'm just doing an example. 1 would certainly not go in a circle here, but that's just visualizing how the anti-knight move works. Next we have arrows. Digits on an arrow must sum to the digit placed in that arrow circle. So whatever these two numbers add up to goes in there. And finally, we have X sum. So this is also, I think I've only set with this once, and that's for this puzzle. A number outside the grid gives the sum of the first n digits in that row or column, where n is the digit in the cell closest to the given clue. So that is a little hard to understand if you haven't really used n before in reference to things, but what that means is if we determined that this was a 2, just for example, that would be saying that the first 2 cells of this row must sum to 9, which is the clue outside. If we determined it was 4, that would mean the first 4 cells, which means all of them, would have to sum to 9 as well. And so you're looking at whatever the first cell in the row is, and then working out how would you make that plus however many other cells sum up to the number outside the grid. So, with that said, we only have one hint here that's necessary. It's kind of sort of like a 2-in-1, more or less, but it says the X sum clue is where it starts, because row 1, column 1 can only be one number to allow that clue to work. After that, the anti-knight constraint will be your best friend. So, just think about those options. You might have even already spotted it when I was doing the examples. You know, if you made this a 2, what would you make this to sum up to 9? You'd have to put that as a 7, and 7 is not allowed in a 4x4. If you made it a 4, now you've overshot it, because that would mean all 4 numbers are being summed together. And if you do the math on that, 1, 2, 3, and 4 sums to 10, not to 9. So that would be too much. So the sweet spot is this must be a 3. And so now we can ask, well, what would these 2 digits be? If we already have a 3 here, the sum is effectively kind of worked its way down to 6 now. So we would need these 2 to sum to 6 to make up for the rest of that. These must be 2 and 4, and that gives 1 in the corner there. Now that we have some info here, we can place a couple digits, because anti-knight, 3 up here means 3 is not there or there, so 3 must go here. That's not a 3. 3 over here, anti-knight again goes there, so 3 places itself there and puts a 3 in the circle. 1 here works its way out of those. That must be 1. 3 Sudoku by that is there. That's a... oh, Jesus, that is not right. That's a 1, and that's a 1. Then we are left with a bunch of 2 4s. And the way we resolve that is the arrow, because we know this is a 3, we know that's a 1, that has to be a 2 summed with it. That's 2, that's 4, that's 2, that's 4. Anti-knight takes out 2 from here, and that tells us the order of these. So that one took a little longer, just because it was more to read in this one, and X sums are a little awkward to explain, so I wanted to make sure I gave that one, the appropriate amount of time. Now, like I said, I've been doing these roughly in order of difficulty. I'm gonna do this one next. This is the newest one. This had its own standalone video, but now it's just being included in this new packaging of these. It's a little debatable whether this one's tougher than the next one I'll do. I think this one's a little bit easier than the next, so we will do this first. This is another slow thermometer puzzle. Inspired by the first one, I just wanted to make one that was a little more difficult than that first one, which basically just filled itself in immediately when it did that pattern of, that. This one, we have 2 of them. I colored them differently, so it's a little more clear to see which way they're going. But they are the same logic, though. Digits on thermometers must increase or stay the same as they progress from the bulb to the tip. The thermometers are colored to specify the direction each one goes. To be clear, they each perform a U-turn shape. So this one goes this way. That one goes that way. And so for this one, there's not even really a whole lot I can do to hint on this one, besides the same info as the first one. The hint I put on the Logic Masters page is, the only bit of advice that's particularly helpful for this puzzle is to be generous with your pencil marking of each slow thermometer here. Start by taking note of how the low digits must minimally progress, and how the high digits must maximally progress, and go from there. Always be sure to update the pencil marks if needed whenever you place digits onto one of the thermometers. That last little part is a little bit of a reference to when I was testing this. I would often very easily forget that for some reason. Like, I'd have the pencil marks in place a digit, and then forget to go back to the pencil marks and adjust them accordingly. So, the example of how we would actually go about doing the pencil marking here, because there's a lot of options here, and this is a weird shape these take, is that it's bizarre to think, if you're used to normal thermometers, it's weird to think, technically, these could all be 1s. There's no problem with that. Sudoku allows for it, and the thermometers allow for it. So in the minimum case, as when I say minimally progressing, we're looking at in the minimum case, these would all be 1s. This would now have to be a 2, just to increase from that, and then these could also all be 2s. So it's bizarrely possible that this could just be 1, 1, 1, 2, 2, 2. And if we now go back in the reverse direction, we could say maximum, the way this progresses from the maximum direction, those could be 4s, those could be 3s. And the way we do the pencil marks is we do the minimum case, the maximum case, and then we fill in the difference. These could be 1 or 3, but it could be a 2, because we have a little bit of freedom in between, where we could potentially go up by 1 number in the middle, and it wouldn't break the puzzle quite yet. Now we can do the same for the green one. This one's going to be a little bit more interesting. This now starts as a 1 in the minimum case. This could be 2. This could stay as a 2. But this would, even though the Sudoku aspect of it would make this possible to be a 2, it can't be because we assumed that this would be a 2. So this must increase in order to avoid clashing with this. Now in the reverse way, that could start as a 4 at the maximum. This could potentially still be a 4. This would not be because, again, we assumed this was a 4 in that case. So this must decrease to 3, which means that must decrease to 2. Once again, fill in the middle case here. That already is filled in, 1 and 2, 2 and 3, 2, 4. We could have a 3 in the middle there, and then 3, 4 there. And so I did that slow just to really demonstrate how you would kind of do this pencil marking, but that is enough to get us started now, because 1 in this row must go there. And that now forces 1 in this row, which can't go here anymore, that must go there. Now that doesn't help us with the pencil marks, because this could still be anything from 1, 2, or 3. But what we can do with all this is we can say that in this row, 2 must be here, because it can't go there. So 2 does not go there. That must be a 1. That gives us our final 1 in the corner here. And more importantly, this now being minimum 2 means this can no longer be a 2 as well. Which also means this can no longer be a 2, which means that can no longer be a 2. So that gives us a 2 up here. And our final, not our final, next 2 up there, and another 2 there. That is all 4 of our, no it's not. I thought that was all of them. Our last 2 is here. And just normal Sudoku is going to finish this up. These are all 4s now. That's a 3, that's a 3, 3, and 4. So I like that. That takes a little bit more logic. You know, it's not as immediate as just, hey, here's a thermometer, fill it in, thanks. This has 2 of them at least. There's a slightly fancier way. You can see this if you didn't catch the little floating 2 here. The other way you could sort of do this, which is actually the way I spotted first when I was testing this, is you could ask yourself, what if 2 goes here? And you could do this by contradiction, sort of, and say that if this was 2, that would become 3. That could be 4. That would be fine. But it's not fine, because what would this be? If that was 2, 3, 4, this couldn't be any of those. Even if you made this potentially not a 4 and just made that another 3, this would now have to be 4, and you'd have the same problem, where this cell would be impossible to fill. And the lesson from that is that's a different way of proving that 2 cannot go in this cell, because if you did, no matter what you do, this would become impossible. So that was number 5. That was slow. Now we have the last one. This one I think is the most complicated. It's still approachable. You know, it's still a Snackdoku, but this one's definitely the least trivial. Hence why there's 3 hints on this one. So this is not normal Sudoku rules. So that was when I said slight exception earlier. That's this one. So it says this puzzle uses 4 of the digits from 1 to 9. Which 4 digits are used must be deduced by the solver. Place those 4 digits once each into every row, column, and 2x2 box. So it's, you know, in theory, it would be possible this could just be 1 to 4 again. But more likely than not, especially with these cages, it's not just going to be 1 through 4. It could be like 1, 4, 6, 7, or something like that, depending on what the cage totals and all that are going to tell us. And then whatever those 4 digits are, you'd have to then play 4x4 Sudoku with those 4 numbers. And that's what we call a mean mini. Other than that, we have standard rules. We have standard killer cages. These sum to certain things. German whispers, adjacent digits on the green line have a difference of at least 5. And then consecutive pairs, these would be consecutive. Now, I want to see if I left a note here about something. Yeah, I did. Note that Sudoku Pad does not understand the mean mini rule here. So if you use the killer cage calculator, don't trust it. And what I'm saying there is that it kind of ignores the fact that these could be any number combination things. So I'm not even going to open it here. It just really doesn't like the mean mini logic. It doesn't recognize that you could potentially have more than one option for the 15 cage here, and it wouldn't necessarily kind of break normal rules. So I would say just kind of do it in your head instead. So what we have for hint number 1 here is you can immediately rule out one digit from appearing in this puzzle entirely due to the combination of cages in row 1 and the digits that could be used to make those cage totals. And so what that means is we have 1, 4, or 2, 3 to make the 5 cage here, and we could have 6, 9, or 7, 8 to make the 15 cage here. And we don't know the exact disposition of those, but we do know, no matter what, there's no 5 in the puzzle, because there's no 5 in either cage. Hint number 2 says the white dot forces at least one of the row 1 cages to be made of consecutive digits. Pencil marking will tell you which cage that is. So, that's a little weird to interpret. And I didn't want to make it too obvious what that meant, but it's nudging you to look at the white dot is kind of the point. Saying it forces one of the cages to be made of consecutive digits. And so if we pencil mark, again, we don't know the order of these, but we do know the 1, 2, 3, 4, whichever ones it is, the 1, 2, 3, 4 goes down here. And the 6, 7, 8, 9 would go there. Just following our kind of horizontal pencil marking. So this is now saying whatever the combination of numbers in the 5 cages must be made of consecutive numbers, because for this to be consecutive with anything else, it's going to have to be consecutive with the other part of the cage. Which gives us 6, 7, 8, 9 there. And now, as German whisper rules, we can continue our pencil marking combinations of stuff here. That would have to be high to make the 10 cage work. That's a 1, 2, 3, 4. Finishing off our column there, and then 1, 2, 3, 4 there. So this is going to fall apart very quickly once we actually place digits, but the whole grid is pencil marked now. This looks kind of silly, overkill, but we now know, like we were saying, that this must be consecutive numbers to sum to 5. So that just has to be 2, 3. So we can now actually take out 1, 4 from all of those. And now that, actually this is hint number 3, which says from there you can work out what the other row 1 cage must be based on the 10 cage. So it's saying we can work out what numbers are here based on this cage here. And that's because this is now 2 or 3. So this is never going to be a 6 or 9 next to it. To make this sum to 10, it's either 7 or 8. So we can do the same and take out our 6 and 9s from there. So we now know it's 2, 3, 7, and 8 that are in use in this puzzle. And the way we can do our final disambiguation is to use the German whisper line. If this was a 3, we would have to have both of these be 8 in order for this to kind of work, and that certainly doesn't work. So we need to have 2 and then 8. 7, 8, 3, 2, 3, 7, 8, and you can see this fills itself in now. So I went through that one relatively quickly still. Really, most of the logic is just explaining the mean mini thing. Like I said, that's the most complicated of the 6, I would say. It's still generally approachable, hence why it's only 1 star on here. I'm glad that because it's not as trivial as the others, this has the highest rating of all of them, which I think makes sense. It at least has some interesting logic despite being quick. Mean minis are just really interesting to me. Yeah, so those are, at least as of right now, which is absurdly early in the morning because I haven't gone to bed yet. 5 in the morning on January 13th. As of now, at least, that is the 6 Snackdokus that I currently have. I don't particularly plan on making more soon. I really just kind of made that slow one after months of not making snacks. I kind of just made that one on a whim one night because I just felt like it. Maybe I'll have another whim like that soon and make more. But yeah, thank you for watching.